From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Okay, so what are we talking about? So the topic of today is how you could run unprivileged stateful Kubernetes. It's about a project that I started a while ago. The status currently is it's highly experimental, so we will get into some technical details during the talk. And also some demo of that, and I hope everything goes right. If it doesn't, we'll have some interactive debugging, which also might be nice. But if it does, it's also great because you'll get to see some cool stuff. Okay, let's start with the result first because I want to spoil everything. So what will we build? We will build a fully functional Kubernetes without having any privileged or infrastructure pods that are visible in the associated control plane. So right, you will be talking to a Kubernetes API server, you can do a kubectl delegate pods, you will not see anything. In fact, you don't even need to be able to run privileged pods in that cluster, yet you will still have storage, you will still have network, you will still have devices, whatever you want, because those will be plugged from outside into the cluster, and because they are plugged from outside into the cluster, you can also control them. It's in the realm of platform engineering. You see, you provide Kubernetes as a platform, and as if you are the platform provider, you can control everything. Your customers will be seeing only an API that they can consume and work with. Okay, before that, a few words about me. My name is Pascal. I'm a high-energy physicist by training. That means that I like to take things apart and rebuild them. And that's why I went into the cloud native and Kubernetes and container field, because it's something that you can take apart really nicely and build it from the ground up. Currently, I'm working at Artix in Garching, so Germany. I'm a senior consultant. My focus is primarily on cloud and cluster architecture. Also in my spare time, I enjoy cooking, I enjoy hiking, I do like gardening a lot. This is something that I discovered last year. And I've been making music for a while now. Also, a few words about my employer. Artix, we're a company with a lot of experience in Linux and open source. We're been doing data center automation for a while. If you know the Foreman, we do have our own software that's built on the Foreman, which is called Ocarina. But also we're doing consulting on cloud and container platforms, and we're also offering trainings, and we newly have software that deploys Kubernetes. It's our own Kubernetes distribution that we call Hangar. Okay, so why even try to build non-privileged stateful Kubernetes? Let's start with the dilemma of the Kubernetes service providers. There's one term that I heard today that I think describes the starting point of this the best. And the term that I heard today is the platform as a product. Right? If you are a platform engineer, you want to provide a platform, and the platform in itself is a product. You don't want to blend into what the platform is doing. You don't want that the users of your platform can break your infrastructure. Otherwise, SLAs or whatnot might be interfered with. So, in general, when you provide Kubernetes as a service, there's one big issue. That's the dilemma of the Kubernetes service provider. The big issue is that when you're the provider, you want to administer the cluster infrastructure, right? You want to do everything that's infrastructure related and provide a ready-to-use cluster. In order to do so, you require privileged access to the container runtime interface, to all the container interfaces. Container network interface, you need to be able to start privileged pods because you need to be able to interact with how all the namespaces, C groups, and whatnot are managed. On the other hand, your customers, they will consume Kubernetes as a product. And if they're doing so, they need to be able to interact with the Kubernetes API, and ideally, they require super user API access. And by super user, I generally mean cluster admin. So that makes it a problem, because the way that Kubernetes was built and the way that Kubernetes was planned is both of these roles are actually the cluster admin, right? The cluster admin does the infra. The cluster admin does everything that happens in the cluster API, because we don't have any separation between an API admin and an infrastructure admin, at least in the way that usually Kubernetes is built today. So the problem becomes, how do you actually implement a proper separation between these two aspects? And if you are a service provider, how do you enforce, for example, compliance? How do you enforce that no one is able to break your infrastructure or do things that you don't want? How do you implement policies? So idea number one is you'll do the same thing that cloud providers are doing. You just separate the control plane administration from the cluster administration, right? You pull out the control plane of your cluster. This has been done before because that's the way that Kubernetes was originally done. You host your control plane. If you've ever done Kubernetes the hard way, you host your control plane somewhere else. You're running the Kubernetes API server, etcd, and whatnot, just as services somewhere, so that everything that the consumer of the cluster, your customer, sees is the API. And so they cannot break anything that's running under the API. They cannot break the control plane. So how do we do that? Well, we manage the control plane externally. You could do that if, I think in Kubernetes the hard way, you do that by just starting systemd services. But you could also just run your control plane in a different cluster. And because you're providing platforms, why not just provide one cluster? Just provide many APIs. So what you can do is you can go and run your Kubernetes control plane as pods in a different cluster. The control plane consisting of etcd, API server, controllers, whatever you want, and then expose the API server so that you can join external nodes. So we have a managed API. You are managing this API as a service, and anyone else, your customers, can join nodes to that managed API. Cool. Now you have Kubernetes API as a consumable service, right? The API itself has been decoupled. The customer uses the API. They cannot break what you're running underneath it. Cool thing is, I just said the customer cannot interfere with what the API is doing. You can implement policy there. You could implement protection of your API. Since you're also controlling etcd, you can do managed etcd backups, restores, whatever. If you have an ecosystem around that platform, it's easy to integrate with that because the API server is now entirely under your control. And if you plan on hosting a lot of control planes, you can host them without having too much resource overhead. If you compare it, for example, to kubeadm, where you have one VM per Kubernetes control plane node, and if you do HA, that means 3 VMs per cluster. And in that case, if you just host your control planes as pods somewhere else, you can put a autoscaler there and don't need too many VMs, don't need too many kernels, and that makes things more lightweight. So in the end, the way that we solve this conundrum is we say, okay, the providers, the service providers, they administer the cluster infra, so they are the cluster admin of the cluster where the control planes are hosted. The customers, they just consume the API. They can be cluster admins of the internal cluster that's provided by this API. They are cluster admin of the managed cluster. Okay, that's it. Well, no, because we've taken one thing out and have specifically used the term infrastructure and then went to Kubernetes API. Kubernetes API is not all of your infrastructure, right? What about the network, storage, devices, things that we also have interfaces for? The things that run in your cluster, usually as daemon sets. Those things haven't been taken out. If you're looking at any cloud provider, if you take any cloud Kubernetes, you might not be able to break the API, but you can still break the storage providers, you can still break the network there. And why is that so? Well, because infrastructure plugins are usually deployed as privileged daemon sets, and that makes a lot of sense because they know as privileged daemon sets, first of all, they are privileged, so they can provide infrastructure because they have privileged kernel access. On the other hand, they're running on every node, so we have the same infrastructure on every node, and we administer them via Kubernetes because that's the way that is the easiest once you're in Kubernetes land. The only problem is these things are, on the one hand, they're cluster infrastructure. On the other hand, they are cluster resources. Now, going back to the slide that I had before, now we do have a problem, right? Because I just said, well, the cluster admin in the control plane cluster should be able to control the cluster infra. And the cluster admin in the managed cluster should only be bothered by managing the cluster resources. Now, the problem is the infrastructure plugins are cluster resources and cluster infra at the same time. So they fit in both of these categories. What do we do about those? Should we maybe rethink how we provide resources in Kubernetes in general? Well, in order to answer that question, let's have a look at how these things actually work. So the privileged daemon sets provide their resources, be it network, be it storage, be it devices, via well-defined standards. And that's one of the great results of the cloud-native community, that these things have been standardized. There's the container network interface, the container storage interface, the container device interface, and probably a lot more that I forgot to list here. And Kubelet, on the other hand, just consumes the resources via these interfaces. So when I'm on the worker node, at some point, I do have a kubelet running there, and I do have a provider of my resources in terms of a socket, maybe. If we're talking about CSI, that's a CSI sock, or a container network interface binary. Those are things that are just present on the node. Now, if only there was a way to sandbox that kubelet so that it doesn't see these the daemon sets that are responsible for providing these things, yet forward the actual interfaces. So forward the socket, forward the binary into the kubelet. Well, lucky we, because that's what containers have been built for, right? Containers have been built for being able to take things from the outside and just putting them in there by bind mounts, by forwarding things. That's the big benefit of containers, that you don't need to have the infrastructure inside the container. You can have it outside and just forward it inside. So this is a big graphic, and I'm sorry about that. But the general idea is we run the kubelet of the customer cluster as a pod in an infrastructure cluster. So we have an infrastructure cluster in addition to our control plane cluster. And I hope that my, yeah, does that work? Yeah, great. So we do have a control plane cluster. This is I think maybe you have seen that before. So we have a control plane cluster, a cluster where we just host control planes as pods. And we have another infrastructure, another cluster we call infrastructure cluster. This infrastructure cluster is only there so that we can actually schedule a managed kubelet. So what we're doing is, in that infrastructure cluster, we do have just plain old physical nodes. And on that plain old physical node, there's an infrastructure kubelet, the standard kubelet that there should be, right? The usual one. In that infrastructure cluster, we deploy our infrastructure daemon sets. That's great. Now, what do? We run kubelet and ContainerD, cryo, or any container runtime inside a pod. That's what I called an ephemeral node here. It just means that it's a node that's not actually a VM, but a pod, and it can be just destroyed at any moment. And instead of re-implementing storage, network, and so on inside that pod, we just forward the resources from outside into the kubelet container, the ContainerD container, so that they can be consumed. That's the general idea. And the result will be that we have a fully functional Kubernetes without any privileged infrastructure pods visible within the managed API, because now within the managed API, we have a kubelet that follows that managed API, but it doesn't see any of those pods because the kubelet itself will only see the socket. It will only see the binary of the CNI. And cool thing about this is I can show you that this is actually working. Unfortunately, I can only show you that this is working for CNI because I'm not done with the CSI yet, and storage might be the more fun thing, but storage, on the other hand, requires you to write a gRPC server because of the socket thing. And for CNIs, it's much easier because it's just a binary, and that could be a bash script. And if we have time later, we can actually have a look at that bash script. But let's see. There we go. OK. Is that probably I should zoom a little bit more in. There we are. OK. On the left-hand side, you will see the infrastructure cluster, which at the same time is a control plane cluster. So to show you that what I'm about to show you is completely independent on which Kubernetes we are running in. This is RKA2, but it could also be any cloud Kubernetes or whatever you want. kubectl get nodes. OK, so we have two nodes, right? We have an RKA2 server, which means it's a control plane node. We also have an agent. The control plane itself doesn't have a taint, so that we actually are able to schedule onto both of them, which makes it easy to run things. OK, inside that cluster, I've deployed an additional control plane. I'm missing an E. Hosted cluster get deploy. Right? We do have a kube API server. We do have a controller manager. We do have a scheduler. And I also have a kube shell, which allows me to speak with that kube API server, but I don't need the shell, actually. I also have a managed core DNS. And I have a connectivity server, which is a technical detail. This API also is connected with pods that are actually hosting etcd and our nodes. Right? We have a stateful set that's hosting the node. So kubelet itself will be running in these node pods. kubectl -n hosted cluster get pod node 0 minus o JSON. Let's see, jq.spec containers dot name. So we have a kubelet in there. We also have made use of the wonderful sidecar feature of Kubernetes, which means that ContainerD actually starts before kubelet. So what we're having here is an entire Kubernetes cluster as pods in another cluster. And to prove that to you, let's just talk to this API server here. I'll do a port forward. And I've prepared a kubeconfig here. So on the right-hand side now, I'm talking to that hosted API server. And I see there's 3 nodes which coincide with the 3 pods in this stateful set. And the wonderful thing is, inside this cluster, there's no pods. There should be no infrastructure there. On the other hand, let's create something that usually would require CNI, that would require us to have configured a network interface. I know in the cloud you could do this also without extra pods, and you will see how to, you've probably seen that done in the Kubernetes the hard way again, but what we're doing here is different. What we're doing here is we are starting a pod in this managed internal cluster, and by starting a pod, we are actually allocating resources in the environment cluster. So the resource that I'm talking about here is a network namespace and an IP address. And to show you that, ctl get pod -n CNI shim watch this looks a little bit flaky, but it will get better in a second. So currently, on the left-hand side, I'm watching the environment cluster. I'm watching the infrastructure cluster, and now I'm creating things in the internal cluster. Let's see if I still have this in my history. I do. So what I'm doing now is I'm creating in the internal cluster a deployment with 5 replicas. These 5 replicas will be 5 pods in the internal cluster. And in order to get them an IP address, things will happen in the outside cluster. And watch. Let's just do kubectl get pod -o wide -f. Watch. It would have been watched. I'm sorry. Kubectl get pod. Right, in the inside cluster, I've started pods in the naming scheme that you would expect. Right, this is just plain old deployment. It creates pods for me. These pods are created in the inside cluster. When kubelet actually created these pods, it called into, or the container runtime called into the outside cluster and said, give me a pod because I need an IP address. So there was a pod created here. We took the IP address and forwarded that to this internal pod. We'll see every pod in here has an IP address that was allocated on the left-hand side. And that means every communication between pods on this side in the internal cluster actually happens between those dummy pods that we created in the infra cluster. So now why is that cool? Because, first of all, it works. That's one of the reasons why it's cool. The other reason is why it's cool is it's completely independent on what's running on this left-hand side. Right? I could have taken any CNI in my infrastructure cluster and just forwarded. This is completely agnostic. I didn't write any bash script that says, this is Calico, this is Cilium, this is Flannel. No, it's just said, create a pod, take the IP address, and forward it. And you can do the same thing. Unfortunately, I cannot show you because it's not done yet. But you can do the same thing with the container storage interface. You can do the same thing with the container device interface, because all of these interfaces were built to do exactly that, to create resources and forward them into a container or pod, respectively, because that's what Kubernetes is all about. And to show you what the last benefit of that is, now imagine I'm the infrastructure provider. As an infrastructure provider, I'm only working on the left-hand side. I can now enforce policy on what people are doing in this cluster on the right-hand side just by doing things in here, because that's the other reason why I chose RKE2, because by default it comes with support for network policies. I can deploy a network policy in my infrastructure cluster, which is the environment, which isolates things in the managed cluster. Let me show you. kubectl exec ti. Let me exec into this pod. And I can, for now, curl any other pod in that internal cluster. So network is working. That's a proof that it's actually working, which also is cool. But you see a reply there. That's cool. But what's even cooler is I can go in the infrastructure cluster and just prevent that from happening. Creating a default deny policy here. There's no network policy in that internal cluster. There's nothing that the admin of that internal cluster could delete or break or whatever. It's a policy that comes from the outside. And this will take some time and run into a timeout. And of course, if I remove the policy on the left-hand side, it will all work again. And I could do some more interesting policies here, but that would, I think, break the scope of this talk. So let's get back to the slides. The benefits of this is, as soon as we have that, you've seen that in the managed cluster, there are no pods at all. So there's no reason anymore to allow for privileged pods in that managed cluster. You can just enforce policy and say, let's say the API server just forbids privileged pods in general, because we don't need them anymore. They're coming from outside the infrastructure components. These managed clusters that you can create this way are minimal. You've seen there's nothing in there. They start up rather quickly. I didn't show you that because I was too afraid that I might break something, because it's built on a pile of bash at the moment. But they are complete. They are feature complete. You do have network and you will have storage at some point. And the coolest thing about this is it completely decouples the application administration that happens in the managed cluster that you could let your customers do from the actual platform administration. And that's the dream, right? Now this time really, thanks for your attention. And I hope you have any questions. Oh, wow.
Yeah, that's pretty cool. Let's go for the first one. How does your solution compare with vCluster?
I came prepared for that question. Okay, so how does it compare with vCluster? vCluster is doing a different approach. The overall goal of this is the same, and we're trying to do the same thing in the end, but the approach is slightly different. So what vCluster is doing, vCluster is providing a modified kubelet, right? It's a modification of kubelet itself. You have kubelet, you have something that talks to your API server. The managed kubelet will talk to the managed API server and prevent it's actually a real kubelet. It will tell it, I am a kubelet, I can start pods. And in reality, it's not a real kubelet. It will just talk to another API server and tell that other API server to create the pods there. So in vCluster, you're mocking kubelet. In this approach, the kubelet that we're running is a real kubelet. It will create real pods itself, but we're mocking the CNI and the CSI and the CDI. The benefit of that is that you can plug different things there. So you don't have to swap everything. You can just change one component and delegate it to the infrastructure.
Okay. Next one is, can pods in managed cluster A connect to pods in managed cluster B or on infrastructure without network policies?
That's a great question. I'll have to reread it again, sorry. Can pods in managed cluster A connect to pods in managed cluster B or on the infrastructure? Yes, they can. That's a wonderful question. Yes, they can, if you do not prevent that with network policies in the infrastructure cluster. So you can build some pseudo mesh on top of that, but yeah, let's put the mesh in quotation marks. Yeah.
Next one is, can the network policy also be created in the managed cluster?
Again, a great question. It can. However, in the managed cluster, as things are now, there's nothing that watches this network policy. So the way you would actually implement that is by having a controller that watches network policies in the managed cluster and syncing them to the infrastructure cluster so that they are implemented there, because that's the only place where we have an actual CNI that watches these.
Let's go with this one. Are you aware of Gartner Seems similar, just with a different level of isolation.
Yes, I am, and I think the question sums it up quite nicely. It's a different level of isolation. There's a ton of approaches in this direction. I got to be honest. So there's a ton of approaches in this direction. There's also OpenShift virtualization that allows for virtualizing clusters where your managed kubelet nodes are actual VMs that are deployed via KubeVirt. That's yet another approach that does that. I think SUSE are doing something very similar with their hyper-convergent whatever. Yeah.
Okay, I hope you're ready. We have more and more questions coming in. That's very nice. Next one is, can you archive this behavior with RBAC or admission controller?
I assume the question is, can you achieve that?
Yeah.
And kinda with RBAC, not with RBAC, because RBAC is scoped inside the managed cluster, and if you give people cluster admin access, that doesn't matter anymore. You can do things with an admission controller, so you could plug an admission controller into that hosted control plane. However, that will not prevent people from reading about the infrastructure components. That's the one thing. And the other thing is you still will have to set up infrastructure in every managed cluster. And the way that this is built, you need to set up infrastructure once in the environment cluster, in the infrastructure cluster, and every managed cluster can use that. So you don't need to deploy your infrastructure multiple times. It's the same logic that applies for containers in general. When you can take something out of the container and share it, why not do it?
Why not run the CSI, CNI, etc. stuff just on the node directly and bake them into the OS image?
That's an awesome question, thanks. The reason why so you could do that, and probably as a cloud provider you want to do that, but it takes away flexibility from you because you will have to know exactly how these things work. Think about it. I don't know if you've ever done Rook Ceph before, or if you've done Longhorn before. These storage providers come with an entire operator that you will have to rewrite in order to not schedule things as pods into the managed cluster, but rather write systemd services. And that's a ton of effort. And in this approach, you can just use whatever the cluster, the infrastructure cluster gives you.
Another great question, what could be the use case of a CSI if it's just an ephemeral environment?
Well, the CSI itself allows you to talk to storage, and the storage itself will be hosted by the infrastructure cluster, which is not ephemeral. The only thing that's ephemeral are the nodes of the managed cluster. So they are these throwaway pieces, right? You can just drop your node instantly. You don't have to care about it because it doesn't take any effort to set it up. You don't need to spin up the infrastructure pods because they are outside. They're in the infrastructure cluster, and there everything could be persistent. So you're not losing storage in this sense. I hope that answers the question.
The next one isn't that just a Kubernetes-ception? I think that's the case here, but
yeah.
Sorry, I don't know who asked this question, but I'm sorry.
Is that a technical term? So is there something like Kubernetes?
No, I think it's
okay. Yeah, then yeah, it is because
it is related, I think, to the next one, which is gvisor for clusters, in the way that gvisor offer its own isolation mechanism, which is fairly close to what you've built. So that's
it's the same thing, but not on kernel level, but on container whatever interface level.
The next one is ContainerD inside ContainerD sounds like a hell to debug. I would say yes, but...
Well, it's not that bad because you can actually do kubectl get kubectl logs -c ContainerD. So you can actually review the ContainerD logs without looking somewhere else. It's easier once you get everything running. What is hell to debug is finding the magic paths that are shared between containerd and kubelet because they share a lot of directories, and you will, since these are different containers, you will have to bind mount those together with bidirectional mount propagation, and yeah.
I don't really get the next question, to be honest, but let's try it. Can you expand this to ephemeral clusters, but with way faster startup than provisioning virtual machines?
A wonderful question. Let's see how this cluster was actually created. Oh, sorry, yeah, okay, of course. So if I were sharing my screen at the moment, I would be showing you a directory of YAML files which contain all of that control plane, etcd, and the nodes, and of course, of the managed cluster, and of course, setting that up as a kubectl apply, and it takes roughly 30 seconds for the first node to show up. So it's not super fast, but the reason why it's not super fast is because I haven't preloaded the images onto the nodes. Otherwise, you could probably start a cluster in a second.
Okay, I think we already answered the next one, but let's try it. What's the difference to vCluster? It looks like a configuration-less vCluster sync.
Yeah, that's exactly the point. It's configuration-less in the sense that we don't have a controller that's running outside that has to sync things. Rather, kubelet proactively, or better, the container runtime in the managed cluster proactively spins up these synced pods because it has access to a kubeconfig. Yeah.
Let's go for the two last. How good is this scalable? Will it increase latency?
Probably depends on which latency we're talking about. It increases the latency for starting pods, because when you start a pod, the call to the container network interface in the managed cluster will require starting up a pod in the environment cluster, in the infrastructure cluster, and that takes time. However, these pods themselves are just dummy pods. They're running on the pause image, so that depends entirely on the amount of time that your CNI in the infrastructure cluster will take. But it increases latency, yes.
Last question, a more generic one. What is the use case of this?
I'm thinking of two potential use cases. One of them, which should be more short-term, because again, this specific thing about this is still experimental, is if you want to spin up small clusters really fast. Because that you can do with this. In the long run, probably you can do managed Kubernetes-as-a-Service, specifically with very short response times when it comes to scaling the nodes.
Okay, thanks a ton for answering all those questions and for this great talk. A round of applause for our speaker, please.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.